let's have a look at the question. And a lot of this, they don't give you a diagram, which is not very nice, but is part of the point. Can you interpret what's going on? David walks along a straight road. At one point, he notices a tower on a bearing of blah, 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 with a certain angle of elevation. Okay, so he's there. He looks forward. That's 0 degrees, right, where he's going. But it's at 53 degrees, true. So he looks at a certain angle. He looks up. There's the tower, okay? He then walks further along, and then the bearing changes, and then he looks up, and the angle of elevation has changed. Now, just before I draw this all up, the angle of elevation before was 21, and now it's 26. So what does that actually mean about where he is in relation to the tower? He's come closer, hasn't he, right? I suppose if he was standing directly beneath it, the angle of elevation would be 89 or whatever, right? But the whole point is that you've got to understand, wrap your head around spatially what's taking place. Find the height of the tower. All right, so here's the first tip I'm going to give you. You know how I say, draw a diagram. Draw a diagram. With 3D trig, you should draw 2. Okay, so first, let's think about where he's going in 2D space. Let's look down, bird's eye view, and see what's going on. Okay, the first thing I'm going to do, this is like not even a diagram, this is like pre-diagram. Okay, first, what is the first true bearing? Okay, so this is bearing 1. And they say it's 0.53 degrees, okay? Now, you spent a while thinking about like unit circles and trig and all that kind of thing. So you have to remember, true bearings, they start from north, and then they go clockwise, don't they? Clockwise, right? So 53 degrees would be 53 degrees that way, okay? So it's something like this. That's 0.53, okay? So that's the direction he looks at first for the tower. When you have a look at bearing number 2, okay, it's whipped all the way around. It's a reflex angle, 342 degrees, right? 342 degrees. Now, which way is this? Draw yourself another basic compass rose, okay? Again, we start at north, and to be at 342 degrees, he's come this way. He's gone clockwise all the way past 90, past 180, past 270, and now he's in this quadrant over here, right? So that angle's whipped all the way around like that. In fact, it's going to go a little further. It's almost all the way up to 360, isn't it? Which would be back to north. Okay, so that is now the bearing the tower is after walking a distance, right? So that angle there is 342 degrees, right? So now you can see, like I had to draw this before I can put pen to paper on like, where's he going? I don't know what direction he's going in until I can work out that's the direction he's looking at one point, and then he's looking that way. So now roughly, I'm orienting in my head, I guess he's kind of walking from left to right. You see that? Right? He looks at one point, and then he goes this way, and now it's over there. So it's like somewhere in here is where he's looking. Okay? Now, I just conveniently got my compass roses in the right spot, but it might not always be like that. If these were swapped around, you have to think, which way is he actually walking? So now I'm going to do my bird's eye diagram, and I guess it looks something like this. There you go. Okay? So there's David 1, that's where he starts. There's David 2, and here is the tower. Okay, so this is all just in 2D space, right? Before I leave this, I'm going to use my understanding of these angles here to put angles inside the triangle, okay? We'll start with the first one. That one's easy. See, there's 53 degrees going that way, right? So what's this angle inside the triangle?
90 minus.
It'll be the complement of 53 because it's this guy here, isn't it? Right? So that makes it, I think, 37 is what I heard. 37 degrees. That's in there. Okay. In here, to get this angle, where is this angle on my compass rose? It's there, isn't it? It's there, right? So it goes 90, 180, 270 is that 3/4 way around the circle. So what's left is 72 degrees. Is that all right?
Yeah.
You see what's going on? So now, using this, before I leave this diagram, might as well finish this diagram while I'm there. What's the last angle? Angles on the triangle, 71, right? 71. Okay, so this is good. I've got this top down, right? Oh, one thing I'm missing. How far do you walk again? 230. Where is that?
D1.
It's D1, D2, isn't it? 230 meters. Great. Okay, so there's our first diagram, right? And look, like we haven't even started solving the question. The real challenge of this question is here. It's not in the trig. The trig is easy. It's like 3 lines. It's 3 lines of trig. It's all in understanding spatially what's going on. Any questions so far? Okay. Now what I'm going to do is I am going to take this and now I'm going to look at it from an angle because I need to put height on there. I need to draw a 3D diagram after this. So I've got D1 still going to D2, okay? And I've got the tower over there, but the tower goes up, right? So now I've kind of got flat ground here, and here's the tower like up this way as is vertical, okay? So now the diagram I drew before has T on the ground. I'm looking down, right? So the tower is just a point in space. But here, now I've got the top of the tower in here. Right? So I've got one angle of elevation, right? And then I've got another one over there. Now, here's one of the benefits of doing 2 diagrams, right? Not only can I really understand what's going on here, but because I've got all this information on this diagram, I'm not going to cloud it on this diagram, right? I'm going to use this strictly to store like up-down information and not worry about this other stuff which I've got more clearly illustrated elsewhere. So, what are the angles of elevation? We said they go from 21 degrees. 21 degrees. There's his first angle of elevation.
What?
And then 26 degrees.
So then what's 37 then?
Okay, so where is 37? 37 is an angle on the ground, right? It would be here, but I don't want to put it in. You see what I mean, right? Yeah. Okay, we don't. I didn't draw it as is. Like, it's just a straight line. I suppose I could have drawn it at an angle, but it'll just, like, it could be going up like that, but it doesn't make a difference to how I actually solve the question.
Is it for us? The second one?
Okay, so, stay with me, guys. Stay with me. What I've got here, this is my bird's eye view, right? So this is looking directly on top. So this is a 2D diagram. This is my 3D diagram. We have a fancy name for this. I've heard you guys, some of you mention it. This is called an isometric diagram, right? Isometric diagrams are very hard to draw well, especially when, and this is what like 99% of students do, they try and do their bird's eye diagram on the same diagram as their isometric one. So they've got bearings happening here and it's just confusing like crazy. Okay? So that's all the information I'm going to put on there for now. Yep.
But if you use your diagram as part of the working out, would it be better to put everything on the isometric?
This is my working out.
So that's fine.
And I would argue that this is 10 times clearer than any diagram where everyone tries to put everything all
So
in
you
once.
are allowed to do it.
This,
Well, there's no...
no, I plan to show you a method that's really, really dodgy and will get you 0 marks.
That's part of the working out.
This is all my working out.
Oh, okay.
Which is why, by the way, when people ask me for working out paper, like I've said this before, right? You shouldn't have working out paper and answer paper. Your working out is your answer, okay? It's all there. Like, I'd present all of this, okay? Can we keep going? Yep, all right. Now, I'm after a height. I'm after a height. Where is the height I'm after?
There.
It's not on this diagram, is it? Because this is a 2D diagram. It's over here, it's there. That's H, okay? Now, look at this, right? I'm after a height. That's a length. I don't know anything on this diagram about lengths except for a single number, right? That's the only length I have on this diagram, right? So clearly, I must go from here, from this diagram where there's the length I want. I've got to transmit something from here over to here where there's a length I can use. Does that make sense? Right? That's why I have 2 diagrams, okay? Now, watch. This is the way I'm going to do it, okay? I've got to go from here, 3D, isometric, over to a bird's eye view, right? And get this information over there. So clearly, I'm going to need, I'll put it in another color. I'm going to need this side here, and I'm going to need this side here. Can you see why? Because those sides are on this diagram. There they are, right? Best investment you can bring into an exam after a template and a calculator is a set of color pencils, okay? Or highlighters will do, okay? Well,
I didn't
Because
think
they
about
say
red.
on this is black and blue pen.
highlighters are to help you understand what's going on, right? They would be marked, but does this not make things clearer? It doesn't make. All right, now, these are the lengths I'm after, okay? What are they actually equal to? Well, I've got a height here, I have a length here. This is a right angled triangle, right? In fact, I've got two of them, yes? Because it's an angle of elevation, okay? So I've got an angle, an opposite side, and I want an adjacent side, right? Like, look at this length up in here. It's no use. You can ignore it. Why? Think about it. It has nothing to do with getting over here, right? It's not going to help you. So I want opposite and adjacent together. That's going to be 10. Okay. So I'm going to do it like this because in my head, to trim down as much as on the diagram as possible, you'll see I'm going to go to a direct step, which might be a bit confusing. So I've got a red side. Okay. Now, in this triangle, this right angle triangle here, tan 21 is opposite on adjacent. It's H over red, right? So if I want red, I'm going to have to swap these guys, right? You see that? Tan 21 is going to go on the denominator, okay? So this is in fact is going to be, to write it in the most concise way, H cot 21, okay? You're going to see cot a lot when you're doing these angular inclination 3D tree questions, okay? Using exactly the same logic. This green guy over here, right? That's H cot 26. So far, so good? Okay, now I've got all I need and I can forget that this is a 3D question now. Because I can come over to my 2D diagram, H cot 26, H cot 21, right? And I've got all I need to work out